Hello, we are Group 4. Welcome to our topic, Reducing Project Duration, one of the key concepts in project management. Now let's find out why reducing project duration matters in project management. There are three main benefits that are time to market advantage, unforeseen delay, and reduced project overhead costs. Now, let's look at our case, the Ventura Baseball Stadium. Ventura Baseball Stadium is a 47,000-seat stadium project managed by G&E Company, started on June 10, 2019. We receive the networking information table and use it to build the project network. This diagram shows the sequence and dependencies of all activities. As you can see, our project has two critical paths. Now, I'd like to draw your attention to Activity 20. This is the inspection phase. Whether we follow critical path number 1 or 2, everything must converge at this crucial milestone to bring the project to a close. Before analyzing the solution, let's look at the key theories. First is the critical path, which is the longest sequence of activities in the project network and determines the earliest possible project finish date. Since critical activities have zero slack, even a one-day delay can delay the whole project.
But suddenly something happened.
An, what's up with the Venture project?
2 workers got seriously injured pouring concrete. We face massive delays and heavy penalties.
Are you serious? This could break our company.
The original 6-week buffer was reduced to only 2 weeks, even though more than 1 year of work remained, increasing the possibility of missing the April 3, 2022 deadline. G&E faced a $500,000 daily penalty for late completion.
Here are 5 options we offer to address this problem.
So how to reduce the project duration accurately? There are several approaches. First, start-to-start lag allows a successor activity to begin as soon as the predecessor starts, so tasks can overlap and save time. Scheduling overtime means asking the current team to work extra hours instead of hiring new workers, which helps increase labor while avoiding extra recruitment and training costs. Let's analysis 5 options are given by Young first, because only critical activities can directly reduce the overall project duration. Option B. Assign overtime to complete the infrastructure in 100 days, not in 120 days. Option C. Introduce a start-to-start lag, whereby construction of the roof begins 70 days after the start of bundling roof supports. Option D. Introduce a start-to-start lag, whereby installation the scoreboard can start 100 days after the start of construction of the upper steel bowl. Since those options aren't on the critical path, they won't reduce our overall project timeline. But options A and E, however, are on the critical path. With option A, reducing the seat installation duration from 140 days to 120 days accelerates the following activities and brings activity 15 down to 645 days. With option E, applying a 100-day start-to-start lag allows seat installation to begin on day 400 instead of day 420, which also shortens the succeeding activity by 20 days. However, because the final inspection is also constrained by other tasks, such as roof installation finishing at day 660, the total project duration is reduced by only 5 days. As a result, a new critical path appears, now including roof installation. To achieve a greater reduction, we should then focus on activities on this new critical path. At this stage, only option C can shorten that path. Therefore, option C should be combined with either option A or option E. To decide which combination is better, we need to consider resource constraints. Although option A can accelerate the project, it also creates significant risks. First, overtime is expensive, usually costing 1.5 to 2 times the normal labor rate. Second, excessive workload can increase worker burnout, stress, and even staff turnover. Finally, overtime may lead to fatigue, which can reduce productivity and work efficiency. Therefore, these risks must be carefully considered. In contrast, option E, using a start-to-start relationship, does not create the same negative effects. It simply allows the activity to begin earlier than originally planned. Clearly, the benefit of option E outweighs the benefit of assigning overtime in option A. Therefore, we reject option A. By combining options C and E, the project can achieve the optimal reduction of 15 days in total. To manage the delay, G&E should first prioritize critical path activities. Also monitor near critical paths to prevent them from causing new delays. This strategy can help finish the project faster, avoid penalties, and stay competitive. But it may increase costs, cause burnout, and reduce quality. Here is a suggested memo to send to Mr. Percival Young. We suggest that combining options C and E, fast-tracking both the seats and the roof, compresses 2 critical paths simultaneously, recovering 15 days. This completely avoids expensive overtime costs and guarantees worker safety after the recent accident.